Okay, so first let's write the product, and we assume that the hydrogen is going to go to the carbon number 1 in the first case. And by the way, which two carbons we are considering, 1 and 2? And the one is having more hydrogens. So when hydrogen goes to that one, so it will be a major. So CH3, CH2, CH, and then CH3. So it's butane, 2-ol, and the other product is going to be what? CH3, CH2, CH2, and then CH2OH. When hydrogen goes to this H now, so here, that is number 2 option. So OH is going to go to the 1. So this is butane 1-ol. This is butane 1-ol. Here are the two products, right? So at this moment, even if you can figure out, that's well done. If you do not, now you know the mechanism. Once you go to the mechanism, you would be able to identify which one is major and which one is minor based on the stability of carbocation. Yes, Aisha, go ahead. Yes. If you draw all the, I think you are talking about the displayed one. Yeah, so even if you draw the displayed formula, it's perfectly all right. Okay, now if you follow the mechanism, we know that it's electrophilic addition reaction. Electrophilic addition reaction always takes place in 2 steps, right? So in the first step, one atom added. In the second step, the other part of the atom. In between, there is a carbocation intermediate formed. When carbocation intermediate formed, we are concerned about the stability of carbocation because carbocations are not stable. So we are concerned. So that gives us a hint that we are not going to have an equal amount of products. In this case, we have to look at the stability of carbocation and then decide which product is going to be formed in this case. So let's start the first one. It is CH3, CH2, CH, double bond CH2, and then HOH. So if I write HOH, so I'm trying to write in all different forms in which the examiner presented. So instead of writing it upside down, now I'm writing it like this. Pay attention. This side is partial positive. This side is partial negative. Now please pay attention. Excuse me. Pay attention, please. Now in the first step, the electrophile part, that is going to add in the chain, the hydrogen part. In order to add, we need electron pair. Where does that electron pair will come? Yes, the double bond electron pair will be used. So with the help of a curly arrow, we represented this thing, that the double bond wala electron pair is used to make attach hydrogen. Now the hydrogen has two options, 1, 2, 3, 4. Either it could attach with carbon number 1 and carbon number 2. So we have an option of 2 carbocations. First carbocation is the one that's carbon attached to the first carbon. So it is going to be CH3, CH2, CH positive, and then CH3. Okay. And this is a secondary carbocation. Okay. So secondary carbocation. On the other hand, there is another possibility is that, just 1 minute. If CH3, CH2, CH attached here, then CH2 positive on this side. So this is the possibility of primary carbocation. No, tertiary not possibility because यही दो attach हो सकते हैं. So tertiary तो इसमें है ही नहीं. अगर methyl propene, yes, that'll be a tertiary. Okay, but in this case or in propene, they are the secondary. Right? Propene में ऊपर हमने किया था ना. Look at this. This was propene. You see? But if it is a methyl propene, yes, that'll be a tertiary carbocation. But that'll be more stable. Okay, here you go. So, Aisha, yes, go ahead. Because this is what we learned in the previous part. Okay, if the carbocation has 2 hydrogens and 1 alkyl group, 1 carbon, so we call it primary. If it has two carbon, so it's a secondary. And if it has three carbons attached, so it's a tertiary. This doesn't go with the carbocation only. This goes with the haloalkanes and alcohols as well. Given the alpha carbons, the carbons under consideration are having more than one carbon attached directly, they are secondary, one carbon primary, and there are three carbons mean tertiary. So this is we learned in the previous section when we started this. So okay, fine. Here, now which one is more stable? What do you believe? Secondary, because there are two alkyl groups. Now I'm not showing the bonds. I'm just highlighting how many alkyl groups attached with the carbocation in the secondary. CH3 on one side and CH2 CH3 on the other side. Two alkyl groups. Both of them pass their electrons towards the carbocation, making it more stable. Okay, as a result, so obviously this is going to be a stable carbocation. Okay, and this is kind of unstable or less stable. Okay, so next product, the OH negative. When hydrogen accepted this, please look at this. You have to put one arrow here as well, up or below. This electrolytic fission takes place and both electrons are taken by OH, right? So the OH that comes formed here, it's a nucleophile. This nucleophile goes in the second step and makes a bond with carbocation here and carbocation here. So these curly arrows carries the meaning. So you can't just put them in any way. You should be your tail should be touching with the electron pair and head with the carbon that is going to have them. So the product is in this case CH3, CH2, CH, OH, and then CH3. That is the major. A few molecules may be formed in this case as well. So CH2, CH2, and CH2OH. So butane 1-ol, a very less amount because of the unstable carbocation, and butane 2-ol is the major product that is going to be formed in this case, right? So this is how we look at the electrophilic addition reaction mechanism, how the major and minor products are formed, right? If you have any question, otherwise we are going ahead. Next is the oxidation of alkenes. Any question? Okay, so we carry on with the next is